For our next example, let's look at determining this limit as x approaches 1 of 3 minus x over x minus 1 quantity squared. Now, you might notice right away that if we just try to plug in 1 here, it's not even defined. So we're going to have to figure out what's actually happening here by looking at our values as we get close to 1. So we want to start by making a table here and figuring out what's sort of happening. We want to look at what happens as we approach from both sides. So I'll start sort of the same way we've started before. We start looking at values here and see what happens. So here I've got what's happening on the left, and then maybe I'll make a similar table for what's happening as we approach from the right. And we enter the 0.5 in and we get 10. When we enter 0.9, we get 210. When we enter 0.99, we get 20,100. And when we enter 0.999, we get 2,001,000. This seems like something is a little different from what we've had before here. So let's just go ahead and I'll fill in the other values here and then we'll talk about this. So as we plug in values closer and closer to 1, they don't seem to be approaching any specific value. In fact, they just seem to be growing rather quickly. We went from a 2-digit number to a 7-digit number, going from 0.5 to 0.99. So what is happening and what can we say about the limit here? Well, what's actually happening is that in this graph, this is a vertical asymptote here. And from college algebra or a previous class, you might be able to recognize that. So if we look at the graph of this thing using Desmos, we see that we do have this vertical asymptote here that's happening here. So what are we going to say about the limit then when this happens? And when this happens, we are going to say that the limit is actually equal to infinity. Now, philosophically, there's a problem with that because infinity isn't a number, it's an idea. So when we are going to write that the limit of something equals infinity, what we're really saying is the following. We're saying that when this happens, that the limit approaches a, it means that if by getting closer and closer to that value of a, we can make the function as large as possible so that that value is always increasing the closer we get to f of the closer we get to a, f of x is increasing. So if we look at a couple of pictures here, we could have some sort of function going like this in this first graph here, and maybe on this second graph we have something coming down like this. And in this first graph, what we would be able to say is that the limit as x approaches a from the left of whatever this function is, f of x, equals infinity. And on the right over here, we could say something similar, that the limit as x approaches a from the right of f of x equals infinity. So as we get close, as we move in towards our value of a from the right, the values are going towards this vertical asymptote and increasing, and the same thing happening on the left here. Now we could have something similar going to negative infinity as well. So if, just for an example here, we could have a function doing something like this. And then on the right here, we would say that the limit as x approaches a from the left of f of x equals negative infinity. So we are going to want to distinguish whether that function is sort of decreasing at that vertical asymptote or increasing at the vertical asymptote. And the same way as before, we need the two infinities to agree in order to say that the limit exists. So for this example on the right here, we would say that as the limit as x approaches a of f of x, we would actually say that this does not exist because from one direction it's going to negative infinity, and from to the other direction it's going to positive infinity. So anytime when you're calculating something numerically like this, and as you get closer to the values just are either getting super big, positive, or being really negative, chances are that's going to be an infinite limit here. A couple of examples that you've probably seen the graphs of before that might be important would be the function, the natural logarithm of x. So remember that this graph looks like this with this point happening at 1, 0. And it's got this vertical asymptote happening at the y-axis. So in this example, we would say that the limit as x approaches 0 of this ln of x is actually equal to negative infinity here. Along the same lines, you might remember the graph of tangent of x. And this is the function that looks something like this, and it's got these asymptotes happening at pi over 2 and negative pi over 2, and then it repeats at 3 pi over 2 here. And so we would have this. And so you could also talk about the limits as you approach from the left or from the right of these things. So as in a couple of examples here, the limit as x approaches pi over 2 from the left, so that would be approaching along this curve here as we approach pi over 2, we would say that that limit of tangent of x is equal to infinity. And if we wanted to go from the right-hand side, the limit as x approaches pi over 2 from the right is going to equal negative infinity, because we see the behavior there that this function is going down to negative infinity. And you can really make a statement about limits in general that a vertical asymptote is what happens anytime one of these limits is true, that the limit as x approaches that point A is either infinity or negative infinity.